We are now moving on to an interesting part of the Earth, the cryosphere, the frozen water. Here are the learning outcomes for Unit 8B, so go ahead and pause the video and write these down. Here's an overview of the video. Mostly I'm going to talk about the different forms of frozen water on Earth, including everything in this list, and then talk a little bit about the ancient preserved atmosphere within ice cores. I have this photo over here, which I think is really quite an amazing photo. It is an actual photo. It doesn't look real, but it is. And it is a glacier in Argentina, the Perito Moreno Glacier. And there's a hiker here, and it's a sunset. And this glacier is clearly starting to break down and melt and form some really interesting spires and ice forms. Okay, so let's start with glaciers. So glaciers are fields of ice that are on land. And that right there is something that many people are not clear on. Some people think that when they see icebergs floating, or pictures of icebergs, that those are glaciers. But no, those are icebergs. Glaciers are on land, and they form on land when there's more snow in the winter than melts in the summer. So it's an accumulation of snow, and eventually the weight of that snow gets heavier and heavier, and it compresses the snow, and it actually forms some layers. Those layers can be counted to indicate seasons, because warm and cold seasons make slightly different variations in the layers. Glaciers are categorized as being at least 100 years old. A couple pictures here of glaciers. This one has a surface that again looks like the one from Argentina on the previous slide. And now here you can see how this glacier is following a river valley, and it looks streamlined, and those grooves and lines are actually due to the flowing of the glacier. Here's a smaller glacier that's coming in to join this larger one. So glaciers flow downslope just like water goes downslope in a river because of gravity. Now sea ice is something different. Sea ice forms over water, over the ocean water, and it freezes out of the ocean water. This only happens in places where the ocean gets really cold, and the water that freezes out is essentially fresh water. The salts of the ocean are not incorporated into the ice. So these are big freshwater plates of ice. They melt and grow depending on the season, and they're a very important habitat for Arctic animals. So polar bears are land animals, but they do a lot of their hunting by going on sea ice and grabbing seals out of the marine environment. So the disappearance of Arctic ice is of significant importance to animals like polar bears. Okay, ice sheets are a completely different story. They are much, much, much bigger. Glaciers cover at least 20,000 square miles of land surface, and they are thousands of years old. We only have 2 ice sheets left on the planet. Now, before, when we had the last ice age, we had a lot more in the way of ice sheets, but right now the only 2 remaining are on Antarctica and Greenland. And they're shown here sort of for comparison. You can see that the Antarctic ice sheet is much, much larger than the Greenland one. But what's interesting here is the height. So this bar represents 3 kilometers, and 2 miles is about 3.2 kilometers. So almost 2 miles here in thickness, and in Antarctica much thicker than that. So these are not small little mountain glaciers that are a couple hundred feet thick. There are some images here of Antarctica. So Antarctica is of course a giant continent, but we don't know much about the rocks because they're covered with ice. Here we can see in this picture that there are little bits of rock and mountain peaks exposed here and there in Antarctica, but not a whole lot. This image over here is showing the thickness of the Greenland ice sheet, with the thickest being kind of in the center here at about 3,200 meters or 3.2 kilometers. So again, about 2 miles, and that is what's shown here. And then the ice gets thinner and thinner as you move farther away from the center. These are the thickness of ice. The thickness of Greenland's ice sheet in various areas is measured pretty carefully year after year because we can use it as an indicator of how much ice is melting due to rising temperatures. So the ice of Greenland is studied in a lot of detail to try to tell us a little bit about global warming. Now, as I said, there were ice sheets around during the last ice age, which ended about 10,000 years ago. And here's a cartoon kind of showing the extent of that ice about 13,000 years ago. After the ice sheet melted, you can see that there were several features left behind, lots of deep pockets that later filled with water from the ice, from the weight of the ice gouging the land. Now right here, you may be familiar with these 5 lakes. These are the Great Lakes. And I'm going to show you which one is Lake Erie. I'm just pointing to it right there because I'm going to mention Lake Erie again in just a moment. Now we'll move on to another concept called an ice shelf. And this extends from an ice sheet, which again is on land, out over the water. So here is an extension of the ice sheet that's sort of floating. It's kind of being buoyed up by the water, but it is connected to the ice sheet on land. And large pieces of ice shelves can break off and become icebergs. In 2016 and 2017, we had one of the largest icebergs break away from an ice sheet down in Antarctica. So here's Antarctica, and the little red box shows the Antarctic Peninsula, which kind of reaches and stretches out towards South America, and that's shown here. And then this region up here, which is in the lighter blue, is the Larsen C ice shelf. Remember, it's connected in the west to the ice sheet. And right here is where an iceberg broke off, and that iceberg is also shown in this picture. The iceberg was the size of the state of Delaware, and apparently had 1 trillion tons of water within it, which was enough to fill Lake Erie 2 times if it melted, which is why I was showing you Lake Erie. Here's a picture of the broken iceberg. So this is the iceberg here. You can't see the Larsen C shelf. It's off in the distance. And this is a smaller piece of it that broke away because it broke into many little pieces around its edges especially. But this is the whole ice sheet. So that brings us to iceberg, which are pieces of glaciers or ice sheets that have broken away and are now floating in the water independently. As Earth continues to warm and glaciers and ice sheets start to break apart, more and more icebergs are falling into the water. Finally, the last type of ice I want to talk about is permafrost. And this is one that you might not have heard of. So this is a permanently frozen layer within the ground of Earth. It consists of soil and gravel and dirt, but it's all bound together by ice year-round. So it's permanently frozen ground is a way to think of it. Because the Earth is warming, of course, permafrost is also starting to melt. And studies have shown that permafrost warmed by about 6 degrees during the 20th century, and widespread thawing is predicted to continue throughout this century. So if the permafrost thaws, well, then water levels can rise in the oceans because the water is going to eventually run into the oceans. And it also increases erosion of these surfaces that were at one time very stable. So now we're going to move on to our last topic, which is actually related to ice. So what have we learned in this class so far about carbon dioxide and atmospheric temperature? Well, hopefully by now you've realized and agree that carbon dioxide is rapidly increasing in our atmosphere, and this is due primarily to the burning of fossil fuels. Carbon dioxide is a greenhouse gas, and so the more we put into the atmosphere, the more heat we trap at Earth's surface. The more heat we trap at the surface, the warmer Earth becomes. Global warming. The graph on the left shows concentrations of carbon dioxide in the atmosphere from 1880 to 2010, and that is the red line. And then the blue line is average global temperatures, and that scale is over here on the right. So you can see that temperature does vary quite a bit. It isn't a steady increase, but if you look overall, it is increasing. And down here, we might have the lowest point around 56.5 degrees. This is in Fahrenheit. And then at 2010, we have 57.9. So we're only looking at maybe 1.4 degrees of an increase, but that is a very significant increase and is enough to start melting all of the glaciers. On the right, we have a time series that you saw in our ocean acidification lab that shows increasing levels of carbon dioxide in the atmosphere in red, as measured at Mauna Loa in Hawaii. That's the Keeling curve we talked about. In green, we show data from carbon dioxide levels in the adjacent ocean. And there's a lot of variation here. There's no doubt it's not nearly as tight of a curve as this one up here, but you can see a general increase. And those same waters then were measured for pH, which you can see is slowly moving down. And so the scales here have been cut off, but pH is lower when you go down, higher when you go up. And so pH is going down as carbon dioxide levels go up. So on this graph, we're looking at the last couple decades. On this graph, we're looking at maybe the last 100 years. But we actually have information about the carbon dioxide levels in the atmosphere for the past 800,000 years, almost a million years. So here we have carbon dioxide concentrations, and then here we have thousands of years ago with the present being over here. So that's today, 100,000 years ago, 200,000 years ago, etc., etc. And then, of course, in recent times, we have gone off the charts. As I am recording this video today, the carbon dioxide concentration is 420 ppm. There are natural variations in carbon dioxide, and these correspond to times when we have glaciations or interglacial periods. How do we know the composition of the atmosphere 800,000 years ago? Well, that is where we come back to ice, because ice traps atmospheric gases. Even today, ice that's forming is trapping little tiny samples of the atmosphere that's around it while it's freezing. And so ancient ice traps ancient atmospheric gas, and then we can measure that gas carefully in the lab and say something about the carbon dioxide levels, which then tells us about the ancient temperatures. So I'm finishing up here with a slide of scientists working down in Antarctica, looking at ice. This is a very interesting little carved out section of ice. They've put some stuff above the top, but this is really open to the sky here. And you can see the layers, the annual layers of the ice really well here. This is the WAIS, the West Antarctic Ice Station. And so these are people that are constantly working in the bitter cold, in crazy conditions, trying to understand our planet and what is recorded in the ice cores. And that is the cryosphere.